Good morning to Dr. Farahia. My name is Alvin Dong Kiong. My comment number is 201332008. Today I will present about the mini project for the IBS score. Introduction. IBS score drives modernization by promoting installed building system (IBS) with off-site construction and prefabricated components. Prefabricated component means some of the materialized precast concrete panel that can be built in the factory. Then there was decreases the time cost, and IBS is endorsed to address industry challenge, and the IBS score quantify the adoption advanced building techniques. This also can let the IBS increase in the standardization, leading to faster construction, improved quality, reduced error, and sustainability. For the modular coordination, establish a standardized grid of building components, enhancing efficiency and innovation. Standardization in modular coordination streamlines off-site prefabrication, providing flexibility for designer and predictability for contractor. Means they can change the shape they like, and there is more flexibility for the client. Overall, the building industry progress depends on both modular coordination and the IBS score, ensuring efficient cost saving and quality improvement. Like I can make model for the modular coordination benefit. Modular coordination has several benefits. The freedom to develop a variety of architecture shapes inside the defined framework is advantageous to designers, and construction is completed more efficiently for contractors. Size, component size, and alignment are predictable. All teams consider modular coordination facilitate a more efficient building process that saves money, time, and improvement. This is the IBS score formula. It has three parts. First is the structure system, and two is the work system, and three is the other simplified construction solution. For the structure system, the formula for the QS is the construction area of a structure system, and QST is the total construction area of building. For the AS is the IBS factor for structure system from table. For example, if I have a total area is 200 meters square area of a building is a total, and I will pick a 100 meters square to be made in a precast column and beam. The precast column and beam, the IBS factor is 1.0. So we can put in the formula. It's a 100 per 200 times 50%. Why 50%? Because for the structure system, they can get a 50% mass. For the work system, 20, and the other simplified construction solution is the 30. Now, you calculate that 100 over 200 times 50%, and times 1 is the 25%. For the other 100 meters square, I put in the precast column and institute being using reusable formwork. Then you can calculate that the answer is a 20%. That means for the structure system, the result is a 45%. Then for the IBS score, need to achieve 70%. Means other work system that need and the other simplified construction solution need to sum out in the 70%.
Hi, my name is Eric Low Kai Jian. My matrix number is 2133212. Today I'm here to present about the positive impacts of IBS system. IBS system brings innovative methods and technologies that not only streamline construction process but also encourage sustainability, making it an essential component for sustainable growth. So there are some positive impacts of IBS system on construction for sustainable development. First is resource efficiency. IBS promotes the use of prefabricated and standardized components in order to reduce material waste. As a result, companies may improve production processes and reduce unnecessary materials, resulting in more efficient resource utilization. The controlled industrial environment also allowed for material recycling and reuse, which contributes to a more sustainable building strategy. After that, time efficiency. IBS modular design enables parallel building operations, which drastically cuts down on project completion times. Shorter building times result in less resource consumption over time and less negative environmental effects than longer development periods. Shorter building timeline additionally minimize the impact on nearby population and ecosystem. After that, the third positive impact is energy efficiency. IBS frequently makes use of robotic assembly and precision cutting as well as other modern manufacturing techniques. With this accuracy, less energy is used during the building phase than the conventional on-site techniques. However, because standardized and well-insulated components are used in IBS construction, the energy efficiency of the building is frequently higher. After that, the fourth positive impact is reduced site disruption. IBS reduces construction-related noise, dust, and disturbance to the surrounding area by reducing on-site activity. This is particularly important in cities, where using conventional building techniques can be inconvenient and harmful to the environment. IBS improves the built environment overall sustainability and livability by minimizing the disturbance on site. Lastly, the positive impact of IBS system is enhanced safety standards. IBS control manufacturing environment guarantee that building materials follow to high quality and safety requirements. This leads in structures with improved structural integrity in addition to lowering the chance of accidents occurring during construction activities. Because safer construction methods put the health and safety of both current and future occupants first. They are consistent with the ideas of sustainable development. In conclusion, the implementation of the industrialized building system (IBS) marks a critical step towards attaining sustainable development in the building industry. In addition to reducing on-site problems, improving safety standards, and streamlining construction project overall environmental impacts, industrialized building system (IBS) also support the long-term resilience and reliability of the built environment. IBS becomes a key technology as society focuses more and more attention on sustainability, encouraging more mindful and environmentally friendly building practices. Thank you. That's all from me.
Hi and good evening. My name is Jin Kok and my number is 211-31830. So today I will actually present about the IBS core of the part A, which is a structural system. In this structural system, we actually evaluate the column, the beam, the slab, and also the groove trusses. Here is some of the examples that we use in our project, which is the precast column, and then we're using the bubble deck and also the beam of the bubble deck. And last but not least is the preferred metal roof trusses. So for this one, yeah, very curious, like what is bubble deck? So for the bubble deck, it's actually a precast slab, and then it's actually a half slab, and then with a lot of the bubble on it. And then for this one, it's actually very flexible to us to having our beam sizing or actually to add on our beam. It's because when actually we remove our bubble, and then the bubble set is actually can become our beam already. Yeah. Alright, so let's go next. Alright, so I wanted to present about the IBS score, which is the 1.1 about the floor. Like just now what I mentioned, is using the bubble deck, which is a precast concrete slab, and then together with the precast column. And then last but not least is in situ beam. So for this one, it's actually flexible to our project when it comes to we want to add on some of the beam in our bubble deck. So with this, as you can see here, actually I write down is the area of the ground level and also level 1, which is a 258 meters square. Yeah, and then actually in total we having the 395 meters square. And then for this floor, right, we actually having the IBS score factor, which is a 0.8. So how we actually calculate it until 26, which is we using 258 divided by the 395 and then times with the factor 0.88 and times with the total score in the part A, which is the 50 of the marks, and then we will actually get the 26. Yeah. So let's go to the second, which is the roof. So like what I said, actually our roof system is actually using the preferable metal roof trusses. In this case, in this project, we are actually using 137 meters square for this one. Yeah. So actually the IBS factor is 1.0. So how we calculate is actually using 137 divided by the 395 and then times with the factor 1.0 and then times with the total 50 marks of the part A. And then we actually will get 17.5. So in the total, in the part A will be actually the 26 plus the 17.5. We will actually get 43.5 lakh. Yeah. So that's all for me.
Hi, my name is Sheng Sam. Material number is 201332034. Now I'm going to present the calculation of IBS score part 2 and part 3. In part 2, the IBS score will calculate the wall system. For the wall system, we use the precast concrete wall panel, and for part 3 is other simplified construction solution, which is the precast concrete slab panels, precast concrete beam, precast concrete column, and also door and window. We use the IBS manufacturer. So in part 2 calculation, the wall system, we calculate the ground floor, and for the first floor is total length is 144. The coverage is 100%. We use the wall system for all wall. Hence calculate times the IBS factor 1.0. For the total area is 144 and the maximum score is 20. Hence we get the 20 score for the IBS in part 2. Next, for IBS score part 3, we calculate for the other simplified construction solution. In this part, we will calculate for the utilization of standard component based on MS1064, which have beam, column, wall, slab, doors, and windows. For the IBS, for the usage of beam is 79%, column is 100%, wall is 100%, slab is 10.9%, door is 83%, window is 63%. Because of the slab is 10.9%, which have not satisfied for the IBS score percentage usage, we get the 0 for the IBS score for slab. The other component, we get the full mark of the IBS score, which is 4, and also the 2 for the window. Hence we get the maximum score is 18 in this part over 30 marks. After calculation, we get the 81.5 total for the IBS score in this project. That's all for my part. Thank you.
So, greeting to my respectful lecturer, Dr. Farahia. My name is Kong Yew, and my metric number is 2013322042. So now I'm going to present about the part that I've done in the IBS mini project. So for my part, I'm doing for the drawing of the building. So the project that we have chosen is a 2-story bungalow houses, and there are a dining room, a kitchen, a living room, a den, a toilet, and a garage for the ground floor. So for the corner of the building, I've marked as the C at the plan, and then the column size that we have used is 250 millimeter times 250 millimeter. The beam size is 300 times 300, and the door size for the front door is 1,028 times 2,133, and for the garage entry to the living room and the den is 900 times 2,100, and for the toilet the door size is 762 and 2,100 height. So for the window size, there is 600 times 1,200, and there are 19 windows at the ground floor, and there is one window size 406 times 610 millimeter for the toilet. So this is all for the ground floor for the component. So for the first floor, there are 3 bedrooms, which are master bedroom, the bedroom 1 and bedroom 2, and there are also a bathroom for the master bedroom, and another bathroom for bedroom 1 and bedroom 2. So there's also one space for them for laundry, which I have marked as WI. And then for first floor, there are 8 windows, which is size for 762 times 2,100 millimeter. At the master bedroom, there are 4 and 2 windows for each bedroom 1 and bedroom 2. So for the toilet, there are 2 windows for each toilet, and it uses the same size as the ground floor toilet. For the column size and the beam size, we have remained as 250 times square and 300 square. So this is for the first floor. So now I'm going to present the front view of the house. So from the front view of the building, we can see that there are 3 windows for the ground floor at the ground for the front, and 2 windows at the first floor, and there are the front door and the garage at the right side. So for the back view, we can see that there are 6 windows, which are 2 windows for the dining room and 2 windows for the living room, and there are the 2 larger windows for the master bedroom at the first floor. So for the left side view of the building, you'll see that there are 3 windows for the first floor, and there are 7 windows for the den, living room and the dining room, and there are 1 smaller windows for the toilet. Lastly, for the right view of the building, you can see there are 5 windows for the ground floor and 1 windows for the bedroom 1, and then there are 4 windows for the bathroom and the master bathroom. So that's all from me. Thank you.
In conclusion, this project of double-story house score IBS is 81.5%, which is satisfied for the mini project requirement 70% only. This IBS score emphasizing modern building technique and highlight the precision, efficient and forward thinking of construction. This is aiming for the higher IBS score which can accelerate construction, enhance safety and ensure lasting integrity. So that's all. Thank you very much.